In this video, I will show you some of the techniques I use to create project enclosures quickly and easily using Tinkercad. First, we create the two side panels, paying particular attention to matching the dimensions. Use Ctrl-C and Ctrl-V to make a copy of the first side panel so both panels are identical. Now we create the bottom panel, ensuring it has the same depth as the side panels. Use the alignment tool to align the front left corners, then group them together. Now align the front right side and group them as well. We now have the first half section started. Next, we are going to create a tool to round the edges. The techniques you will see me carry out here are not necessarily the most efficient and are just the way that I find works easiest for me. I have found it easy to work with Tinkercad as it is a very visual tool, and as you'll see, it is also very capable. I'm now making a copy of the tool before I test it so that I won't need to create it again. Now I can use the tool to round the corners off by lining it up and grouping it. As I go around, I create copies, spin them around, and group them in place. It looks like I am very quick with this, so it's worth noting that the video is sped up 3 times. Now I'll flip the tool onto its side so I can do the bottom edge. I will temporarily lift the project off the ground plane to make it easier for this stage. It's always a good idea to periodically spin the project around from different angles and inspect it close up. When I did this edge, I set the tool too short, so I will need to ungroup and fix it. Here, I somehow ungrouped this tool, so I will regroup it before I reapply it. I am extending both tools to make sure they are longer than required, just to be safe. I should also apply a curve to the sides along the bottom as well, but I have left this out to keep the video short. Now to make some wedges. They will be 2 millimeters wide by 2 millimeters high. These will be used to make the supports for the front panel. Now I am making a template that represents the width of the front and rear panels. You will see that I use measuring blocks like this quite a lot. The front wedge is the easiest to position. Just use the alignment tool to align it to the front and then center it. I made it too short. Now, to measure the gap for the front panel using the template. Tweak the size, then group the rear wedge in place. If you plan to make cases this way, you could make wedge templates with a calculated plate along the bottom, so that measurement won't be necessary, and it could be correctly placed using only the alignment tool. Now, it's basically the same process of aligning the front wedge, then centering it and grouping it. Then, we move the rear wedge in place using the template to set the spacing and center it, then group it. And now we make wedge tools for the vertical supports. When we go to group these, it's essential to align them with the top so that the halves will fit together properly. The inside of the case doesn't need wedge-shaped supports, and square cross-sections can be used. I am only using wedges because the templates were already made and I think they look tidier. You need to make sure that the panels are fully and tightly supported on all four sides so that the panel doesn't flop around. The friction of the front panel also helps align the two halves and helps to keep the case held together. It may take a few test prints to get the fit perfect, but it's worth the effort. I'm making this look way harder than it really is. At last, I finally got it right. Now, we position the template at the right corner, set its height, then extend it all the way to the left. And finally, we double its height. Now, we duplicate the base and flip it to make the top and position it. It's a pretty ridiculous size, but keep watching and it will make sense. Next, we will look at why printing your own project enclosures is so great, besides the money savings. You can make part templates and store them away for future projects. Here I have a DB25 connector, potentiometer, and a micro USB breakout template. Let's start with the micro USB breakout. Now I'll shape a cutout for it. Now I'll fit and group the cutout to the place where I want the connector to protrude from. Now let's put a DB25 connector in the front panel. And now the potentiometer. Now let's play.